Welcome to FEA Journeys, the podcast where we explore real career, real challenges, and real decisions behind engineering simulation. I'm your host, Dominique Madier, and for today's episode, I don't need to introduce Tony Abbey. Anyone working seriously in finite element analysis already know his name, his work, and his long-standing influence on how FEA is practiced, taught, and discussed across industry. So Tony is one of the true references in our field with more than 4 decades of experience spanning engineering practice, software development, consulting, and education. So today, the objective of this episode of FEA Journeys is to address the critical importance of training, mentoring, and coaching in finite element analysis. I say that because according to me, many engineers practice FEA today with powerful tools, impressive solvers, and sophisticated workflows. We are very lucky to have them, but not necessarily with the depth of judgment, verification discipline, and the physical insight required to use them correctly. And the result is not just small inaccuracies, but sometimes fundamental mistakes with serious engineering consequences. And I have to say that these issues are not caused by a lack of intelligence or motivation. It has nothing to do with that. But they are almost always the result of insufficient guidance, weak foundations, or I should say the absence of experienced mentoring. So this conversation today with Tony will be a professional discussion between practitioners who have seen repeatedly how FEA succeeds when analysts are properly trained, but how it fails when they are not. So we will explore together how training and mentoring in FEA have evolved, what mindset is required to become a strong analyst, how engineering judgment is developed, and why verification and validation must be a bit. So to conclude this introduction, I want to say that this episode is for engineers at all stages of their FEA journeys. Beginners who want to start correctly, experienced analysts who want to sharpen their judgment, and leaders who are responsible, for developing simulation capability within their organization. So let's begin this discussion with one of the most respected voices in the FEA community. Tony, welcome to FEA Journeys, and it's great to have you here today.
Thank you very much, Dominic. I'm not quite sure I deserve such a wonderful accolade, but thank you very much, and it's great to be here talking with you. Okay.
Thank you, Tony. Okay. So, Tony, you have witnessed the entire modern history of FEA. So I would like to start the discussion today by looking back at how training and mentoring in simulation have evolved over the decades. So according to you, how have training and mentoring practices changed over your 40-year career? And how has the role of the trainers and mentors evolved with the new tools and workflows?
That's a very big question, very broad question. So if I go all the way back, I started in industry in the mid-70s. Started my first job at British Aircraft Corporation in Warton in Lancashire, as was then. That was 1976. So to answer specifically about training, there was no training on FEA, but what I was very fortunate, there was a very deep level training program on traditional stress analysis. I worked in the stress office, was kind of attached to the stress office, so I was very, very fortunate in that it was a solid grounding by the actual lead stress engineers, the chief stressman. He led some of the training classes, and it gave an insight into how to actually tackle problems. That was on one side. I was very fortunate. On the other side, I was incredibly fortunate because I had a very good mentor. He was an engineer who'd perhaps been 6 or 7 years in the company. He was a very smart guy. He was was a physicist, interestingly, and I think physicists make very good kind of excellent engineers if they decide to transition into that field.
Mm-hmm.
But he had a very good practical thinking about, if I could distill down, it was problem solving, thirst for knowledge, but also a keen awareness of errors. I think those were
Right.
things he kind of passed on to me. In terms of training, actually hands-on, again, very fortunate. We had an FEA program called the Walton Displacement Method, which was in-house, and there the one of the guys that created that sat 3 desks away from me, so I could go and ask him about, why have you done this, this, that, and the other. He was very, 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 very helpful. You had to know the right questions to ask, though. You couldn't ask open-ended questions. They had to be very specific, very, very kind of pointed questions.
Yeah, yeah.
In contrast, Nastran was just coming into the company because of the joint projects with MBB and the Italian companies on what was then called the MRCA, became the Tornado. And in contrast there really was no training, and I can remember blindly going through the manuals, the big, thick Nastran
Mm-hmm.
manuals, which
Yeah,
we were
yeah.
kind of transitioning through. And I remember in dynamics thinking, well, which of the 5 dynamic analysis techniques do I choose? And completely nobody could answer that question because it was kind of new knowledge. So it was nothing. Obviously, it was very early days for MSc. There's absolutely no criticism in them whatsoever. But it was very much a kind of teach it yourself, kind of learn quite blindly. So I think that early experience was kind of quite the contrast of experiences. But I think so. The key thing would be, I think, the mentoring at that stage was absolutely essential.
Yeah, yeah, yeah. I understand. Yeah. I like the fact you mentioned the aspect of self training, self training, self teaching. Uh, I think it's still the case actually in the domain of FEA. Many engineers I discussed with are in this situation, and I know that they contact us to in order to have our support for training and mentoring. But I
Hmm.
detect that we still have many engineers in this situation. Uh, I like what you mentioned about that you had access to people close to your desk,
Hmm.
and I think also it's a good help for engineers to have really access very easily. Now it doesn't need to be necessary people physically close to an engineer because we have a new communication technology. So, but I think it's very, I agree with you, very important to have someone, a resource, access to a resource that we can ask a question, submit a problem to discuss. Yeah.
Hmm.
Yeah,
Yeah.
thank you for sharing that. It's very interesting. And with as I said, with the today's powerful and accessible tools, that the technical skills alone are not longer enough. So let's talk about the mindset required to become a truly effective FE analyst. What personal qualities and attitudes uh, do you look for in engineers who want to excel in finite element analysis?
I think it probably goes back to the attributes I attributed to my gave to my mentor back in the day. It's enthusiasm, thirst for knowledge, wanting to seek out information,
Mm.
prepared to make mistakes, prepared to listen to people,
Oh
and
yeah.
a lot of prepared to practice. I think kind of contrasting, that was my early kind of snapshot of what was happening in the mid 70s. Today, there's a wealth of online material. I think like YouTube and other resources where you can go and tap into training material, as you're talking about, like virtual training material,
Mm.
is amazing. There, it's like you've got the wheat with the chaff. You've got an awful lot of rubbish out there on YouTube, but there are some kind of key nuggets. So I think if somebody is kind of in isolation. They're not in this kind of mentoring live community. They don't work with, adjacent people at adjacent desks who can provide this kind of mentoring. Then I think as a stopgap, as an alternative, perhaps, then I think the YouTube information, other say resellers and so on have strong channels and so on. So I think they're wanting to search out that knowledge, go find that knowledge, I think is very key. And then, as we mentioned, practice. So I always used to like to be in a job where it was tougher in the old days because you needed a computer. So you try and find time off the project to carry out little experiments. These days, anybody that's got a laptop, there's plenty of I'd say free software or trial software out there. Anybody can really get themselves in a position where they can start practicing. They can't run the big giant project models, but there's the scope of computing these days. You can learn practice. So see something on YouTube, think, well, I get the broad brush idea, what's going on. Let's, I guess, walk through a typical scenario maybe. There's a new technology you're interested in. You kind of do a search around with GPT and so on. It's really now becoming very easy to do that. You isolate maybe 3 or 4 good training videos. You kind of look at those, research them, and then take that knowledge into your own environment, say with your laptop, with your trial version of the software, and then start to practice, start to do what-if studies. There's lots of classic benchmarks. Start setting those up. The beauty of a benchmark is generally we know the right answer. Sometimes it's not quite the right answer, but in general we know the right answer. So it's like a guide there. So I think if somebody set aside, say, 2 or 3 weeks in the evening or whatever it might be to actually go through that process, there's absolutely nothing to stop anybody, I think, being able to go through that task. So that I think that kind of if we're saying in the absence of formal mentoring, then I think that could become a route through. And that's the kind of enthusiasm, that's the kind of initiative I'd be looking for from if I wanted to employ somebody, for example, in a consultancy job.
Sure. I remember the 3 points: listen to people, practice, and test the benchmark, use the benchmark. Yeah, it's definitively a good starting point. Maybe I would add a personal quality which help. It's the patience with the complexity and iteration. I say that because most of the time we use FEA to solve complex problems. We don't use FEA to solve simple problems. So it's very important to handle the complexity of finite element analysis and to be patient with this complexity, because it's impossible when you are a beginner to obtain good results and the right result with a complex problem the first time. So you need to iterate. So you need this patience to iterate. And I think
yes. Yeah, I agree with you. I think dogged perseverance is the way I describe it. I had an example last week. I'm producing some new training material for a particular client. They have an interest in what's called in the aerospace industry carve-out modeling, and very familiar with displacement boundary conditions pulling through. But it's been quite a few years since I brought through a force boundary condition. So I wanted to demonstrate that, and I wanted to showcase the pros and cons of those two methods. So trying to bring through that force boundary condition, I could not get it to work, and it took me 3 or 4 hours, and then just one little step that I was missing, and it was like that aha moment. Okay, that's what was missing. The process, what I was trying to achieve, in many ways, because I knew what I was trying to achieve, it was very frustrating. I couldn't get there.
Yes, exactly.
So it was this dogged perseverance, I guess. I'm not going to be beaten. I have to think about it, and sometimes it's just a stroke of luck. You literally choose the right option. You've got 3 choices. You choose the right option. Hey, now this is all working. So for anybody that's listening, thinking it's all dried and dusted, we know the route that we're following. Dominic and I both struggle. We go through these kind of learning paths, explorations. We take missteps and so on. That's the nature of FEA.
Yeah, yeah,
In my
that's a,
introductory to FEA, introduction to FEA course, I sometimes think I put people off in the first 10 minutes because I always say FEA is a journey. It's not a tried and trusted step A, B, C, D. It's like, okay, we make mistakes, one step forward, two steps back, whatever it might be to actually achieve the goal. So you're right, patience, determination, that I think also that faith, that belief that there is an answer at the end of it. How do we get to that answer? I think that's also
yeah,
important. I think with experience, maybe that's what experience is. You just know there's
correct.
going to be an answer. So with all the frustration, let's get to that answer.
Yeah, 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 yeah. You're right there. Yeah, absolutely. And thank you for sharing this this experience and this point. Yeah, I think very interesting for the audience. And one of the biggest challenges in FEA today is moving from running simulation to exercising sound engineering judgment. So I want to talk about a little bit engineering judgment. I would like your perspective on how that judgment is developed. How does training and mentoring in FEA help analysts to go beyond the button clicking to develop intuition and physical understanding, according to you?
It is really looking at it's looking at the product, it's looking at the actual components, it's looking at the structure, looking at the vehicle, whatever it might be, and then kind of getting to know the physics of the problem, what the real engineering is. It's great having a thorough knowledge of the theory, both FEA theory and traditional, say in the field of structural analysis, knowing all about how to do things by hand. That's great. But if you can't kind of piece together what a structure is doing, then that becomes challenging, and it takes a while. It takes experience. At the same time, it's a kind of asking questions. It's kind of observing. The two main areas I'm interested in, sort of structural static analysis, if you like, and then dynamics. I think looking at a structure, trying to get some visualization on the static side, what the load pass through that structure would be, what we think the weak points are, looking at bolting, looking at welding, looking at failures. Field failures are nobody wants a field failure, but if you
Yeah,
get a field failure of your component, your vehicle, whatever it is, you want to be all over that and sort of understanding, well, what went wrong there.
correct.
Talking sometimes to designers as well. What's the design intent? This
Oh, I
is
like
where
that
I used
one.
to
Yeah,
I
yeah, yeah.
used to like the drawing board because I could go over and lean on the drawing board. Sometimes I get I get batted off that, get off
Yeah,
my drawing board. But basically, as politely as possible, and as humbly as possible. So what are we trying to achieve? What are you trying to achieve with the design? What is the intent there? And a good designer will have a clear understanding what his design intent is. Might
sure.
be something because it's just very standard. It's almost standard design. I just put these number of bolts, lay this out, and so on because that's what we always do because it makes good engineering. Or I'm trying something different or whatever it might be. So I think observing field failures, talking to designers, test is fantastic as well.
Oh, yes.
If I could have my career over again, I want to embed myself in a test environment to a much
Agree.
bigger extent. So again, there are issues with test. It's not necessarily the real world, but it's a lot closer to the real world. It gives us insight into failure modes and so on. So that is, I think, very important. On the dynamic side, I think that's slightly different. A good understanding of modal characteristics is kind of the equivalent probably to understanding free body diagrams in static analysis, but under a good understanding of modal characteristics, what they are, what they do. And there, we're fortunate, you can go onto YouTube, you can look at satellite vibration tests, you can look at all sorts of vibration tests you can kind of observe in this kind of a virtual world, all sorts of information. But again, this is a real kind of nerdy engineer. Sometimes you're sitting there and you look and see a bridge, or you see I remember seeing like we call it dustbins in the UK, trash cans. See the vehicle that comes and picks up the trash can and moves it back out. I can remember one morning over coffee thinking, "Oh, that's the weak point. When it gets to that point of the apex, that's when the most loads are coming in." So this, some people say that's actually a social misfit, but
Yeah.
maybe a true engineer to some extent. You're kind of thinking about, well, how does that work? That's interesting, and so on. So it's absorbing that real world experience, real world
Yeah.
phenomena, I think, which is again is quite important. And sometimes I don't have a clue. I get a new client comes along, and I want to know, well, what is your structure? How does it work?
Mm.
And so on. And if I miss the days of only doing real training, where I was always looking for an excuse to walk the shop floor, but it's still, you still research the background, what the components are, and sometimes it's just a mystery to me how it works, what's going on, and so on. So it's that, again, it becomes that interesting to then explore that.
Yeah, 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 yeah. Thank you for that. I like those 2 points about developing engineering judgment. Talking to the designer and uh, be involved in with test is so true. That is very important for developing that. And I would add also understanding failure modes, not just the stress plots, and learning when a model is credible and when it is not.
Mm,
Because sometimes it's not credible. So,
mm.
do you think that on this point of engineering judgment, do you think that the engineering judgment can be taught explicitly?
Yes, by probably mainly by mentoring,
Mm.
discussing, guiding, and so on. Um, but then there are some very good courses. I'm thinking like ASME, other courses which are discussing failures. Like for example, one would be on fatigue. There's a very good course by um, out of the UK, and I now have forgotten sorry, it's out of the US, but I've forgotten the name of the author at the moment. But he talks about he's an FAA guy. He does certification and so on. So basically, it talks about the failure modes, and I think so it's not an FEA course as such. It's like to your point, it's really talking about failures and
Mm.
um, the traps that are occurring if you just look at simple theory and so on. So I think that kind of deep level, a long way from the button clicking
Mm.
and the button pressing, but and the menu picking, just kind of that very rich immersion. And I've got to say, I think those are fairly few and far between. That deep level course where you don't really, there's no FEA theory there at all. It's all,
Mm.
to your point, failure modes and so on. So I think um, if you can find them, then they're very good courses to go on.
Oh yeah, yeah, yeah. I think it would be interesting to know the what is the name of this course and of this person. Maybe we can do the search after, and we will put that in reference into the video after.
That
Uh,
would be a good idea. So again, I apologize to that particular author. I should remember your name. I don't. So we'll go and research it.
yeah, yeah, absolutely. So despite all the advances in software, we still see the same modeling mistakes repeated again and again. So let's discuss the most common ones and why they persist. What modeling errors do you see most frequently across industries, and how do they relate to gaps in training and mentoring?
Um, I'm thinking my own experience. What mistakes do I make the most? And probably I would have to say is going to be boundary condition definitions.
Yeah.
It's we we kind of work. We come from a world where it's either built in, simply supported,
Mm.
or pinned, or whatever you want to describe it, or sliding, and it's almost you could say, well, it's either built in or pin jointed. It's almost like binary, and there's no boundary condition which actually satisfies that
No.
requirement. Sometimes it doesn't matter if we're thinking about something, simple description like a cantilever beam, and we're interested in some feature, say halfway down that beam as a
Mhm.
cutout or whatever it might be.
Mhm.
I don't care too much whether it's that, what is the
Correct.
weldment to a backing plate or whatever. But then if I'm interested in a gusset or something where that beam is welded in or bolted into the backing plate, then that becomes very important. Maybe
Yeah.
if there's something like a wing spar, the way that wing spar connects into the frame is very, very important. You might have a front spar quite stiff. You have a trailing edge or a trailing spar, secondary spar, which is more flexible frame.
Mhm.
That load path is immediately governed by that boundary condition which you're modeling. So I think that's probably the number one.
Sure.
There are many, but that one's probably just
Yeah,
just
yeah.
winning the race.
I totally agree. It is the number one. And to be honest, it is still the assumption I'm struggling with many models I'm doing for my
Yeah,
customers. It is the domain where I have to spend the most of time in order to make sure that everything is good in my model. So I
it's still an
completely,
art rather than a science, isn't it? In many
yes,
cases, in that area. Yeah,
completely, it's an art.
yeah,
Yeah, yeah,
yeah.
good point. Yeah. I would add maybe on top of boundary, no, not on top, but after boundary conditions, I would say a common modeling error is overmeshing without understanding singularities.
Hmm.
I see that many often, to be honest, with the problems I'm with the consulting I'm doing. I see very often this overmeshing situation popping in practice. So yeah,
You mean hence the models are too big, they take too long to run, and
yeah,
so on.
yeah.
So you're
Or
you're
the
giving yourself
complete
a
model
resource
is
problem.
refined. Yeah,
Yeah,
the complete
you're giving
model is
yourself.
refined where you can refine only a small region because the complete model is not the zone of interest. A small
Mhm.
region is the zone of interest, but it's meshed very fine everywhere. It's
Mhm.
another common error. Yeah, it's I think
I
it's due
think,
to the fact that it's so easy now to mesh, and we have so
yeah,
powerful of calculation in resource. So
yeah.
nobody is thinking about that, and we overmesh. Uh,
I saw a big assembly meshed. It's probably about 18 months ago now, and it was a nonlinear analysis requirement with contact and some material nonlinearity,
yeah,
and it was so overmeshed. And in fact, the other aspect is bringing in the whole scope of the assembly. It was all kind of sucked in and then meshed and all included in the analysis, and that really it was then became a resource problem. It was
yeah,
taking 6 or 7 hours to turn around this nonlinear analysis, and there were fundamental errors in the model which there was no time to address them. There was no time to
mm,
do that. Um, that exploratory phase of the modeling. When you get a new project, you want to mesh it, see if it works, but then you're probably going to use a coarse mesh to just evaluate what have we got here, what's going on. It was
yeah,
just a deep plunge straight into the full assembly, as you say, exquisitely meshed, but then no chance of actually working that model up to become a good quality production model.
yeah, no, yeah, absolutely, no, yeah,
I think the other major topic to me would be misunderstanding the scope of the physical problem.
mm,
So basically, not thinking about, to your point, maybe a key region that we're interested in. Do we need to run the full assembly? Do we need to run like a full-blooded nonlinear analysis? Maybe we can get some information out from a simple linear first pass to
yes,
understand the load paths or whatever it might be. I
yeah,
think that, and then not not really looking at the back to my previous point, not really looking at the product, not really looking at the component. It's just looking at the CAD coming through, looking at the geometry and treating it as geometry a geometry exercise,
mm,
rather than a physical component exercise. There's an example just came up very recently where, again, it's all sorts of things blended into that. What was the design intent? What does the component do? What does the structure do? And then think about fitting the model into that field, into that particular that's kind of situation.
Yes.
So not sitting back, assessing what's going on, and then saying, what strategy do I take for my modeling?
I like the word strategy. Yeah.
Yeah. And it's an overwhelming temptation, isn't it? So the geometry's come through. I just want to mesh it,
Yeah,
hold
yeah.
it, load it, see what we got there. And I think that's understandable and that's fine. But run a quick course model, get that out your system, then sit back and say, so what have we got here? What's going on? What are
Correct.
the implications? I think
Yeah.
that breathing space, that breathing time is quite important. I can remember one company I worked for. If you were sat there at your desk pondering the strategy, the lead engineer would come and go around. They're like, "Why aren't your hands on keyboard looking at the screen? Why aren't you getting on with the job?" And it's like,
Absolutely.
so I had a big pushback there. I nearly got fired at that particular point. I was a contractor, and I said, "Look, you need to build into each project that thinking time, but to make it so it's measurable,
Mm.
let's actually have an informal briefing." So the engineer would spend, say, half a day planning his strategy, thinking time, maybe playing around with the model, but then there was an informal presentation to the other engineers, what is it we're trying to do? That then actually worked because then the lead engineer was
Oh,
happy because, okay, he's sitting there just looking at not even looking at the screen. His hands are not on the keyboard, but he's going to have to deliver something to me at the end of the day, which is the
oh.
strategy. So that satisfied the kind of the managerial side and the giving you the breathing time as well. So I'd really encourage that approach.
Absolutely. I can only agree with you, Tony. The FEA strategy is a key step. And in my practical basic FEA, it is one of the first lecture. After the first lecture is what is FEA, what to do with FEA. And right after that, it is FEA strategy. And I really love what you said because it's a key point in order to develop the right FEM and to deliver the right results. The key step. If you miss this step, the FEA strategy, the planning, you will produce a wrong simulation,
Mm.
or you will produce maybe a right simulation, but you will do a lot of back and forth, and you see
Mm.
it won't be straightforward. So
Mm.
yeah, FEA strategy is fundamental, and it's not that difficult to apply when you follow the steps of the FEA strategy every time. It's very powerful. I consider that as a method, a tool, the FEA
Mm.
strategy, and as soon as you follow it, it's very, very powerful.
Yes,
Yeah,
there's a series of logical steps you can take, or bullet points you can kind of knock off. It's like a checklist you can go
yeah,
through,
exactly.
and that guides you in the right direction. I think just to emphasize, it doesn't mean you're going to get it right first time, but it gives you. It's almost, I guess it's like either American football or soccer or whatever you want to call it. I guess if you've got a game plan, you've
Yeah,
got some sort of strategy, you're going in with a plan. Now that plan can go, it can go badly wrong, and
yeah.
faced with the real world, things that are happening. But at least you've got a plan, to start off with there.
Absolutely. Yeah, 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 yeah. It's like when you start playing chess, you have a strategy in mind, but as the game is developing, you adjust your game, and yeah, exactly,
Mm.
absolutely. But at least you have a plan to start with, and it's
Yes,
very important.
yes, yeah, yeah.
Yeah,
I think another good analogy would be flying. We both have flying as
yeah,
our experience. Your
good point.
checklist is absolutely, it's
Yes,
can sometimes the difference between life and death, whether you follow the
yes,
checklist or
yes,
not. Yeah,
yes.
yeah.
Correct, correct. Thank you for that. Very interesting. So to me, if there is one area where poor training shows immediately, it is verification and validation. So I would like to explore a little bit how these practices should be taught. How can trainers and mentors make verification and validation an automatic habit rather than a formal requirement?
Um, well, it's part of the checklist, I guess it
Yeah,
would become, but then I like to break it down to absolute simple, basic checks. So, for example, the two biggest embarrassments are if you're doing a linear static analysis and then you do your presentation to the lead engineer, to the client, whoever it is, you've got a stress in there. Peak stress is, say, 6 times yield or even twice yield. It's not physically possible. That puts up a huge red flag because it means you've not recognized the implication of a stress, which is, say, twice yield in a static analysis. Even with a nonlinear material analysis, you present stresses that level or strains beyond rupture, then it shows that you're not thinking back to what it is that you're actually kind of involved with. So stress levels, if we're dealing with statics, would be a key thing. And then obviously deflection. I used to teach a class called FEA for managers. And so somebody with an MBA, let's say, for some reason they're in charge, they're a manager of an analysis group, and it certainly does happen. I would teach them how to startle the engineers at this kind of presentation to say, well, what about, for example, maximum stress, or just, okay, fascinating presentation, but tell me, what's the maximum deflection you see in your model? And then the manager, I teach them and encourage them to relate it back to, are we talking about something like a machine tool, which is very stiff? We're talking about microns, deflections is key. Or we got like an Airbus 380 wing on takeoff, when, I don't know what that is, like 5 meters deflection or something like that.
Yeah.
You've got a sense of what your deflection levels are. So if your model is spitting out meters and it should be microns or vice versa, that's like a big warning flag. So I like to start with those. And I guess I'm really talking about validation there, because you're talking about related to the real world, essentially.
Correct.
Rather than checking the maths, which I think is the verification side.
Yes.
But that was always be my starting point. And in my course, I teach like a sanity check. Does this model make any sense? I set a target of about 10 to 15 minutes to assess the model results and say very quickly, is this rubbish? Is it plausible? If it's rubbish, then I go and debug it. I fix it up. I don't want to waste time sort of committing those screenshots and so on and getting involved with the building the report or going further. I want to have a quick cutoff point. It's like a go or no go. This model's not making any sense to me. I need to rework it. Or this is looking plausible. We then move on to the next step, whatever that might be.
Yeah.
So I think there's all sorts of detail, mesh quality, element quality, Jacobian checks, energy norms, things like that. But I think on the structural analysis side, I say those are the 2 key metrics. On the dynamics side, it's, well, what are my fundamental frequencies? Do they make any kind of sense whatsoever? If I, again, thinking about boundary conditions, we had a problem just very recently. A component seemed to be showing very, very high frequencies within the context of the assembly. So take that component out, nail it down, and say, what are the frequencies, or allow it to be a rigid body motion of its own. That's like an upper and lower bound. So again, it didn't make any sense. So things like that, it's that sanity check is the way I basically describe it.
Yeah, I agree. Sanity checks, very important. Correct. And I think we should keep in mind that the verification and validation should come before advanced modeling. By advanced modeling, I mean, for example, nonlinear static, nonlinear buckling, even dynamic. It's advanced modeling. So it's very important to keep in mind that those verification should be done before going into advanced modeling. It's don't run the nonlinear analysis if you didn't run a simple linear static analysis, for example.
Yeah.
So
I think
very
that,
important.
and I think
It covers the sanity checks.
Yeah. And sometimes you might say, well, what's the point of running a linear model? Because it is a nonlinear response I'm interested in.
Yeah.
But that's okay, because what you're doing is thinking like an art analogy. You're doing like a cartoon sketch. You're doing a layout. It isn't going to be the finished product. It's going to be could be some way from it, but it's that a fundamental layout is checking. For example, element quality checks can be done in the linear model
Yes.
If you're satisfying all Jacobians, aspect ratios, and so on in the simple linear model, then when you transition that to a nonlinear model, then you're in good shape. You
Yes.
don't want to be coming back to fundamental element checks towards the end of your nonlinear complex model, as you're saying, you're thinking, oh, that was the issue. I've got a bad shaped element in there.
Mm.
You check that out earlier with that kind of,
Yeah. Yeah.
and having multi stages in a model I think is also key. Many people coming in new think one project equals one FEA model. It
Mm.
doesn't. It can be a series of models building up to getting the
Correct.
answer out.
Yeah, yeah, good point. Very good point. Yeah, yeah. And it's always easier to do the all those checks with a linear
Mm,
yeah, with a linear it runs faster. So
mm,
definitively we should keep that at the very simple solution level, not the complex level.
mm.
Yeah,
And you might even have to kind of glue together contacts, you bond
yeah,
them together,
yeah.
you switch off material nonlinearity, you switch off large displacement results.
Correct.
So physically, it's not very meaningful, but it's like a shakedown. It gives you a chance to debug your model. Yeah.
Absolutely, absolutely. Thank you for that. Modern FEA software offers incredible capabilities now, but also overwhelming complexity, I should say. So let's discuss how analysts should be guided through this learning curve. How can trainers and mentors help analysts master complex tool chains without losing engineering clarity, according to you?
Um, to pick up your thread there about complexity, I think that's a big difference between going back to the mid 70s and now. Now I can run an analysis, and the scope of that analysis is mind-boggling. You can do
Mm.
things now, simulations which we just couldn't even dream or wasn't even aware of back in that day. So to somebody coming new, I think that's could well be the daunting overload of what methodology do I use? Do I go for, like we're talking about, full nonlinearity? Do I dive into the full nonlinearity straight away because
Mm.
maybe that it seems to warrant the physics warrant it? So sometimes I feel that thinking of like tools before we had simple wrenches and spanners and screwdrivers and so on to handle it. Now you've got complex numerical controlled machine tool kind of thing. But
Mm.
how do I learn how to drive that? So I think just the sheer scope of things that can be done is rather daunting. So I think probably if you've got a mentor, then what should a mentor, what should a trainer be doing? I think showing the fundamentals, moving into the advanced areas gently, gradually, bringing in them, and again thinking like the flying training analogy. When I was a flying instructor, you basically taught in a very sequential way. You
Yes.
explained that this is how the rudder works, this is how the ailerons work. So rudder and stick. You gradually say, okay, pitch, roll, yaw, get that nailed down, and then you move on to the next thing. You're not expecting somebody to land the aircraft in your first lesson, or indeed,
Yeah.
maybe the fifth or sixth lesson. Once they're comfortable with the tools, then you move in. So I think whether you're self-teaching or somebody's training course or mentoring, whatever it is, that think about guiding somebody through. If you throw everything at them, they're going to
Mm.
be kind of confused,
Yeah.
and it's going to be scary. If you dive into a nonlinear analysis, it's not going to converge. There's all sorts of
Mm.
things going on. There's terms you don't understand. All we talked about options. I got 6 different options to choose here.
Yes.
Which one do I choose? So it's like an overload. So I think again, it comes down to that sort of dogged determination. I'm going to
Mm.
set myself a path to go through. Not it's not it's not a sort of like a macho challenge to sort of dive in and put everything in there. You want to evolve towards that. So I think it's very important now. It's the technology is very, very advanced now, and it's demanding, it's stretching to be able to understand it fully. So in many ways, I feel every sympathy for somebody coming into the FEA community now and thinking, wow,
Yes.
where do I start? It was
Totally.
easier back in the day, if that's any
Yeah. Yeah.
consolation.
Yeah, yeah, yeah. But I like the aspect of gradually learning and teaching the concept because yeah, as you said, Finite element analysis is a vast domain, very complex
Mm,
domain. And as I said before, we use finite element analysis to solve complex problems. So go gradually. I think it is the key point
mm,
today to learn finite element analysis.
mm.
And But mentoring means very different things for to different organizations.
Mm.
I would like to focus on the strategies that truly work in developing a strong FE analyst. Which approach have proven most effective in your experience in training and mentoring?
I think the personal mentoring, I was thinking of a particular transition for me. I hadn't done much dynamics when I was working in airframing, um, and it wasn't until I got to a satellite company that suddenly the dynamics are so important to launch and everything in there. Um, and I was very fortunate because again, a guy that I was working with, he was a very senior engineer. He took time out to actually talk to me about what was going on. He actually allowed me to make mistakes. He corrected mistakes I was making on project, and he was a very strong mentor, and he was a
Mm,
fun guy. So it was to me that was he was my key mentor during that period. Um, he also had a good theoretical depth, so he could kind of knock up some basic equations off the top of his head, which was quite amazing. Or he could send, reference not deep level theory, but just kind of practical level of equations.
mm.
He could kind of develop and explain why things were working. So I think that was really that. I think that's why I took that particular direction. Very strong interest in dynamics, and now, that has remained a strong interest. And that was I was probably 15 years into industry at that point.
Mhm.
And then so that change in tack, that change in path was really due to that being in that, obviously, that office, that environment where dynamics is important, but then having that kind of key mentor. Um, Other times I've had people that supposed to be mentoring and guiding, and there's nothing coming back, and
Mm.
there's very little, and in fact it can be quite off-putting if you get that sort of
Yeah,
negative
yeah,
environment. Yeah.
yeah, yeah. Yeah, so true. The project-based mentoring, I think it is the basic,
Mm.
and also the model reviews. Reviewing a model with an experienced people, it's very valuable to learn. So,
I think that's a very strong point. That was the other thing that came out of that little scenario I talked about before, where we kind of bought time in, and then the payback was we had to do a little presentation of
mm,
what our strategy was going to be. That then became, anybody and everybody can sit in on that.
yes,
And so we also tried to persuade the senior engineers, the more experienced engineers, to also take time out to explain. So that towards the end, every project going through that office, there was and it became a fun time. Like, we're going to have a cup of coffee, we're going to sit around, and we're going to yak about this next project that's coming through. So it was very informal, but
okay.
that I could sense that the new engineers coming in, like, oh, what are they saying? I didn't pick that up. It became we talked about like water cooler conversations. It was a little
Mhm.
bit more than that, but it wasn't like a formal briefing session where everybody sat there,
No,
nervous
no,
and not
yeah,
wanting to speak. It was a nice informal. So I think that was if you can achieve that in your office, then I think that's like an osmosis. It's then mentoring by just pure osmosis rather than formal
exactly.
one-to-one. Yeah.
Totally agree. Yeah. I love this kind of approach. To be honest, I think it's very beneficial for everybody, but not only for people who are learning how to do modeling, even for the experienced people.
Mm,
It's yeah, it has a lot of value.
mm,
Eh, we can learn from the failed or bad models for the from the good models, but yeah,
yeah.
it's a very good approach.
Yeah, we used to like to have a wash up at the end too, and sometimes it would be like a post mortem, and it was like, oh great, we get to learn out, those modeling mistakes. was quite funny there. We were doing a lot of impact analysis, drops and so on, and various products. And because it was highly animated, sometimes you could actually see when a model went wrong. So an object would come down, splat, and then you think, "Whoa, that's interesting." So all kind of crowd around the screen, say, "What did you do there?" So that kind of openness as well, learning from mistakes is, I think, is it's all very useful if you've got a
Yeah,
team, and that kind of cross mentoring again can be extraordinarily useful.
yeah, 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 yeah. So that's true. So finally, looking ahead of AI automation and growing model complexity, I would like your view on how mentoring in FEA will need to evolve, and how will AI and automation change what trainers and mentors teach, and what must remain human?
That's a very interesting question, and I've actually been researching that a little bit and doing exploratory work. I use ChatGPT. We're up to
Mhm.
5.2 at the moment, and I'm impressed with the things we can do. I'm always chastened by the things that go wrong. So it's not a doesn't solve all the problems, but it opens up some very, very interesting possibilities. I think many of us have used the ChatGPT and other AI tools. You get into this kind of conversational mode, and I think it's getting to the stage now where it's almost like this assistant or this.
Yes.
I hate to use the word mentor fully, but there's some guidance there, which actually there's some threads of
Yes.
really good a really good kind of vibe coming through. And I
Mm.
don't want to overemphasize it because I don't want somebody to start saying, my next model, I'm going to jump onto ChatGPT and it's going to tell me what to do. Absolutely not. But if you can actually buy the pro version, whatever it's called, it's like $30 a month, whatever, that takes you up to the next stage. Then you can actually you can have a repository of your input as well
Mm.
as the inferences being made from your input, and that gets very, very interesting. And I'm actually exploring right now. I'm thinking ahead to say 10 years time. Maybe training is going to have some aspects of that in
Mm.
it,
Yes.
um, and maybe I guess my analogy would be like YouTube at the moment. There's some fantastic nuggets of real good information on YouTube. Some great, I call them like training or mentoring videos.
Mhm.
There's some appalling rubbish out there, which is like,
Correct.
what is that supposed to be? But it's presented with full, this is the what's up, guys. This is the way to do it, and it's like,
Yes.
whoa, what's this? So I think GPT is probably rather like that at the moment. There's some,
Yeah.
you know, over enthusiastic, completely wrong information, and then there's some interesting guidance coming through. So I'm personally looking forward to exploring over the whatever years we're talking about in the future, and actually starting to think about blending AI sensibly into mentoring. Because
Yeah.
if you've got a fixed static list of like NAFEMS produces competency statements,
Mhm.
and if you've got then but you need behind that the background of what these mean. So if it's like a pool of information, well, AI, and right now, if you said, well, don't go outside that pool of information, stay within that, but then make it into a conversational, evolving mode, then that can be done right now, and that's interesting. I
Yeah.
want to kind of explore that and maybe take that further. Um, but we need all the checks and balances, and we need to avoid the situation when somebody just says, "Great, and this is a real scenario. I've been using FEA for 6 months. I'm working from home. I don't want to go into the office. I have a choice of do I continue with this employment or what? I don't, is transitioning back to office. So you know what? I'm going to become a consultant. I'm going to become a
Mm.
consultant in FEA. And you know what? I'm going to use GPT over my shoulder here I can then run, I'm then a consultant. That
Yeah.
is like a nightmare scenario, but that
Correct.
is exactly what can happen. And I suspect I've seen evidence of, not
You're
maybe
right.
GPT, but again, maybe they're looking at YouTube videos,
Yeah,
and I
absolutely.
think we've both seen that. So that's
Correct.
something that is scary. That's frightening. So it's some blend of live courses like yours, like mine. Virtual courses like yours. Um, real or virtual mentoring, real or virtual training, some blending of that, real world experience, all the things we talked about. But then with this, think of it as like the next replacement to maybe a complement to the YouTube videos which are coming
Yeah,
through. I
yeah,
think that's a very interesting future, fascinating
correct.
area. Yeah.
Yeah, this is fascinating. But I like the word you used about FEA, an assistant. You know, AI assist execution, not responsibility.
Mm.
And it's really the word to associate with AI for in our discipline, at least.
Yeah.
It's really just an assistant, but a very good assistant when used properly. It's a very good assistant. It could be a very good assistant.
I'd say it's like having a very enthusiastic, upbeat, very knowledgeable assistant, but there's a slight touch of bipolar behavior there and sort of
Mm,
completely, occasionally they have a screw loose and then, freak out. So you've got to
yeah,
be aware of that personality that you trust them generally, but you got that eye on them just to make sure they don't do something crazy. So it's an
yeah, very good.
interesting uh,
Yeah.
schizophrenic kind of assistant that you love, but you also hate. You keep an eye on.
Yeah, yeah. No, very well said. So, Tony, to conclude this discussion, I have three short topics. I just want three short answers. Okay.
Okay.
Uh, First one habit every FE analyst should adopt immediately and why?
Oh, um, ah, sort of integrity. Um,
Yeah.
a key. You said very short answer. So uh, full of integrity. Key searching out what is the answer. I think.
Oh, yeah. It's very, very good. Uh, I would say question every result before trusting it.
I think I think I prefer your short answer to mine. I like that.
The second one is one misconception about FEA that must disappear if simulation is to remain a credible engineering discipline.
It's easy.
Oh, yeah, definitively it is the best one
Mm.
because it's never easy.
No.
And finally, one advice you would give to your younger self?
Um, probably get more involved with testing
Yeah.
and the physical prototypes. I think, I mentioned it earlier. If I were to kind of map out my career again, what would I do differently? I'd probably try and get more hands-on in the testing environment.
Hmm. Yeah. No, yeah, that's a very good point. Yeah, thank you very much, Tony, for that. It was a very, very interesting discussion, Tony. Thank you for sharing your thought. I think the audience will love this episode. I'm pretty sure there are many interesting things. To the audience, thank you very much for watching the video. And as usual, you can join me and Tony if you have more questions. And see you to the next episode of FEA Journeys. This is Dominique Madier. Thank you very much. Bye bye.